Hello everyone. Today I'm going to present sequence to sequence models for long-term time series prediction. Problem definition is we are given a history of data and we want to predict long-term future. So there have been already some statistical models defined like Arima model, but they are very bad at long-term predictions. They are unable to predict when new history is available, and they are unable to capture dependencies among very different time series. So before we go to any encoder, decoder, or any other type of deep learning models, we need to define an RNN cell. An RNN cell is defined using a hidden state ht-1, an input is xt, and is this hidden state ht-1 and input xt is actually used to update ht, and this hidden state ht is used to calculate yt. So the advantage of RNN is this hidden state is shared across all the time. So the number of parameters in RNN cell are very less. Also, if we unroll RNN through time, so we'll get a figure like this. Using H naught, we'll get H1. Using H1, we'll get H2, and similarly H3 and H4. So these hidden states are basically temporarily ordered, and will actually help us in uh, determining the temporal and capturing the temporal order in the given time series. We have encoder decoder model, actually DPR model. Uh, in the encoder, we have an input x1, which is used to calculate the hidden state h1, and using this hidden state h1 and x1, we calculate hidden state h2, similarly h3 and h4, and these hidden states are actually uh, used to calculate a global context. Once a global context is calculated, we give this global context as an input to the decoder, and the decoder uses this global context to predict the values y1. Using this y1 and the global context, we predict another value y2, and so on. So to give you the context, these x values are feature vectors, and y1, y2, y3, y4 values are basically the output values, which can be like sales prediction, or it can be like traffic prediction, etc. So this DPR model is actually able to pick trends using multiple time series, and it gives very good prediction even with high variance data. So the other model that I have read is multi-horizon quantile forecaster. Basically, it presents the same encoder model. The input is x1, and it it calculates a hidden state h1. Similarly, x2, h2, h3, h3, and so on. And it again calculates a global context, which is used to which is used to uh, calculate uh, uh, various summaries in the decoder model Z1, Z2, Z3, and Z4. The difference between multi-horizon quantile forecaster and the DPR model is we are not using only a single summary to calculate different predictions. We will use all these summaries Z1, Z2, Z3, Z4 to calculate various quantiles of the prediction. So the fundamental difference is we are not actually uh, we are not only calculating the one quantile, but the various quantiles, and also these quantiles are uh, predicted at every time step. So this actually is so this model is able to pick trends using multiple time series, and also it is very good predict. So this model actually is used for to calculate various quantiles, and these quantiles are used to predict the various y values. And the so this model is very good at predicting long-term predictions, and it can predict even without a history is available. So basically, it is very helpful in predicting even if you don't have history. Thanks.